Let's discuss difference between mutable and immutable in Python. And I can't stress this enough. This is very important. Okay. So look at this thing. The broadly data types can be classified as storage and access and update model. And according to storage, we have scalar and container types. Data type classified as according to access model, data types can be classified as direct sequence and mapping. And we are interested in according to the update model. These are broadly categorized into two models. Two types, which is mutable and immutable. Okay, so just have you read, have you seen any X-Men movies? So X-Men, you see, mutation happens to the gene and they get the superpowers. Yeah, so mutation means able to change. No, the that change. Okay, so that is where this mutable and immutable comes. That is what these mutable and immutable types are also uh, describe themselves. The mutable types can't be changed. Sorry, immutable types can't be changed. Okay, and mutable types can be changed. So can you see this? All these data types, which is among all these types. Okay, all are immutable except list, dictionaries, and set. Okay, remember this. None is immutable. Boolean is immutable. Integer is immutable. Float is, and a string is also immutable. Tuple is immutable. And I don't have to do much to remember this. What are mutable, what are immutable. The only things mutable here are list, dictionary, and set. Okay, so here check the word frozen set, why it is set, and just like list, dictionaries are both are just like a twin brothers. This list and, sorry, not dictionaries, tuple and list. This, yeah, these are also like a twin brothers, set and frozen set. But the naming, check the naming. Okay, frozen. Okay, it's like freezing. We are that's set. Okay, which means that name itself speaks here. Set, that is a data type that can be changed. But here, when it comes to frozen set, which is immutable, that way it is called immutable. That is why it is called frozen set. Okay, so before we move forward, so among all these types, what are mutable types in Python? No, mutable. Set. Yeah, list, dictionary, and set. These are mutable types, and everything else is immutable. Okay, so as we have seen, okay, container types. Okay, and we have seen tuple, which can be defined using parentheses, and it is a container sequence and immutable. And so we have seen list, which is also container sequence but mutable. Okay, so and remember, we learned string. When it comes to string, and you might don't get this no get the impression that string is mutable. No, string is scalar and sequence type. Yes, it is sequence. It we can access those characters using subscription tags, and but strings are immutable. And check this thing: what is mutable and immutable? Okay, so let's define x equal to, okay, colors equal to. So can you define multiple colors? Okay, how do you see just colors? Just put the name uh, colors of primary colors. Let's put primary colors. What is this thing? String. Okay, so how can you, what data type can you use if you want to put multiple if you want to, if you have a requirement of defining multiple values into one thing, in such a case we can use tuple list, right? Yeah. So colors, that way these data types come handy. Okay, I can define red, blue, green. Okay. Okay. And same colors, I'm just calling colors underscore m. Okay. See, I used the underscore all colors. Okay. Red, blue, green. Okay. Okay. Now see, you have a name. If here, what are mutable and what is immutable? A string, which is immutable, tuple, which is immutable, and colors, it is mutable. Okay. So can you refer colors, color? How see, when it comes to computer screen, we refer it as RGB, red, blue, green. But when it comes to the painting, okay, it is referred to RYB, okay, red, yellow, and blue. Okay, so painters use the color, these three primary colors: red, yellow, and blue. Okay. Okay, so but here on computer screen, green is used, and just wanted to replace that with yellow here. Sorry, green with yellow. Okay, so you can refer the green by index 2, right? Okay, so try to put a yellow. Does it work? No, it doesn't work. Why? Because tuple object does not support the item assignment, because tuple is once you define it, and you have to stick to it because it can't change the values inside a tuple. Okay, so let's take all colors. Okay, yeah, and put yellow. Check all colors. And previously we had red, blue, and green. Now what is inside red, blue, yellow? Okay, so if a data type is mutable, and it means it can be changed, values inside can be changed. If data type is immutable, you can't change. Okay, so you may say that okay, a equal to 9, and you may say that if I assign, if I 15, now I'm changing the value 9. No, that is not true here when it comes to integers. These are scalar types. Okay, so you are not changing 9 because you are repointing this variable a to the value 15. Okay, remember this re-referring. Remember just the variable here, the a is pointing to 45, and if we assign another value, b is pointing to 45, and if you put another value, let's say 3.14, you are actually it's like a hook. Okay, so previously I assigned a b equal to 45, and now I assigned b equal to 3.14. Previously it was referring to 45, now it refers to 3.14. Okay, variables are like hooks to refer those to get those values from memory. Okay, so you can point this hook to anything, anywhere. Do you understand? So in fact you are not changing anything in any uh, you are not changing that value in memory. Do you understand? So that way integers are also immutable. Okay, so that there is a id function. Okay, id in the Python, where which refers the, which is equivalent to the address in the memory. Okay, okay, if I assign a is having 15, if I assign a 99, now check the id. Is it same? Okay, so previously when it was 9, it was referring to this address. Okay, but when I assigned a 99, it referred to different address because the 99 was created somewhere in the memory, and we repointed by assigning that value to a. So we instead of instead of referring a value 9, it is referring 99. So the address is different. Can you see? You get it? Can you see that you get 99? If you refer 99 also, which is referring, the where it is in the address. Okay. So here in this RAM, our whole RAM, if your RAM is 8 GB, 4 GB, or 16 GB, this whole RAM is addressed, byte addressed. Okay. So this is not in Python. This is not, it may not represent the exact address, but is equivalent to the address of that value in the memory. Okay. So that way, do you understand uh, that way? Do you understand this thing? Yeah. So previously, see, now a equal to, this thing is happening, a equal to 45. Okay. Now a equal to, I assigned 3.1. Check the ID. Okay. Now if I assign a equal to 3.14, or let's put a b equal to 45, ID of b. Now if I assign a b equal to 3.14, instead of referring, think of it as a kitchen. You have a jars, and you have a label, peeling off label from one jar and sticking onto the another jar. Think of it. Okay, this b is a label referring to 45 previously. Now this label, I'm labeling another value. Okay, it is, see, this is different from other types in the data types in other programming languages. In other programming languages, variables acts as containers. Okay, you put value into that, but here these are mere references to values in a memory. Okay, so that way, if I assign a b equal to 3.14, now check the ID. It is different. Okay, yeah, it is different. Don't be confused here. It is 99. It is 98. Okay. Okay, so that way, so previously b referring to 45, and if I assign b equal to 3.14, instead of pointing it to the 45, it is points to the 3.14. Okay, that way, are you changing value here? No. So do you understand? So that way, all are immutable. Okay, so there you are assigning a value means that you are pointing this variable to another value, but you are not changing that value, okay, in the memory. Okay, so for a scalar types and for container types, okay, so colors you defined, what do you have here? Name. Okay, name is a string. Name, can I refer this 0 or 1 r, right? Instead of r, can I put another value here, p, b? No, it doesn't work because string is immutable, right? So the way I can refer those characters by index, but I can't change those elements. Do you understand? Okay, because string is immutable. Remember, all string methods, it doesn't matter what string method you are trying. None of those string methods change the original string. Okay, so if I actually name, okay, name dot upper, it returns a new string, but original name is intact. Do you understand? Okay, it as a result of calling this method, it returns a outcome. Okay, modified string, but not original string is but original string is not modified, which is intact. Okay, so why? Because this is immutable. But when it comes to list, list is having all colors. Okay, it has how do you check methods of any type? You see, the keyword for a list data type is list. Okay, you can create empty list by this list function. Okay, these are called Okay, now you have all colors. Okay, so check what are the methods. You can check what are methods of list this way. Remember dir function. Okay, so check dir of tuple. What do you see here? There are exclude these magic methods, and you see you don't have any methods for the tuple except count and index. Okay, because these two methods don't change the you know anything. Just they just return. But list is having other methods because uh, they mutate the values in the list. Do you understand? Okay. Okay. So here take all colors, and you have a all colors dot reverse. Okay, now original string is modified. Check original list is. Can you see? Previously what it was? It is red, blue, green. Now it became yellow, blue, red. Why? Because I called the method reverse. Okay, this is a contrast between a string and a list. Okay, so since a string is immutable, all string methods don't make any change, can't change the original string. Instead they return, they construct the new string and return that string, that modified string. But when it comes to a list, since it is mutable, okay, some methods do change the original data structure, original list defined values in the list. Okay, so that way, so tuple is having, do you have a tuple which is a color? Okay, and can you call reverse? No. Okay, so it doesn't support because it is immutable. Okay, and you can't add anything into that. Okay, so that is overall, that is the difference between um, mutable and immutable. You know, according to update model, all data types can be classified as two things: mutable and immutable. Mutable types can be changed and immutable types cannot be changed. And the only mutable types in Python are list, dictionary, and set. All other are immutable, and we have seen that some people do get the impression that if I assign a equal to 4 and if you reassign a equal to 9, of course I'm changing an integer. Why can't integer called as a mutable? No, that is a misunderstanding. Integers are immutable. Here variables are mere references. Okay, if you assign another value instead of pointing to that previous one 4, integer points to the 9. Okay, but actual value in the memory is not changed, that is intact. Okay, so that is difference between mutable and immutable. And do you have any questions?